If we consider our solar system is typical of billions and billions of other similar systems, then where are all the extraterrestrials? The universe should be full of intelligent life by now that would create some kind of signal that's easy to detect. Yet, we've seen and heard nothing. There's one possible solution to the unnerving silence of the cosmos, and it could be the most chilling answer to why we've heard from no one. Because if an alien civilization does exist out there somewhere, they certainly know we're here, and that's something that should scare all of us. You may have heard the term Fermi paradox before. In its simplest form, the term asks the question, if intelligent life is common in the universe, then where is everybody? You might be thinking that the physicist Fermi wrote papers on the subject, and that his life work was based around finding aliens, but this couldn't be further from the truth. Enrico Fermi was a physicist who created the world's first prototype nuclear reactor. He never really wrote much about extraterrestrials. Fermi was chatting with colleagues at a lunch in Los Alamos about a cartoon showing aliens emerging from a flying saucer carrying trash cans stolen from New York City. That's when Fermi asked, "Where is everybody?" Everyone understood he was referring to the fact that there wasn't any solid evidence of alien visits to our big blue planet. The conversation then turned to the topic of interstellar travel, where Fermi concluded interstellar flight might not be possible, might not be worth the effort, or a technological civilization doesn't last long enough to invent interstellar travel. Keep in mind that Fermi was studying this in 1950, when rockets hadn't yet reached Earth's orbit. The so-called Fermi paradox, which questions the existence of extraterrestrial civilizations, actually misrepresents Fermi's views. Fermi didn't question the possibility of alien civilizations, only their ability to have interstellar travel. So what is the Fermi paradox if Fermi didn't create it? In 1975, an astronomer by the name of Michael Hart penned an article in which he said, "They are not here, therefore they do not exist." Hart's claim was that if smart aliens existed, they would inevitably colonize the Milky Way. He believed that if they were anywhere, they would be here by now. But since they aren't, and we've seen no signs of aliens, it means that humans are the only intelligent life in our galaxy. And if that's the case, then looking for intelligent life elsewhere is probably a waste of time and money. But then another famous physicist named Frank Tipler came along in 1980 and elaborated on Hart's assessment and asked the big question, where would a civilization get the resources needed to colonize 1 billion stars? He came up with an interesting idea where a civilization could build an artificially intelligent machine comparable to the current human level that could replicate itself. If you sent one of these out to a neighboring star and told it to build copies of itself using local materials in that system, then you could send those copies out to another neighboring star until the galaxy would be crawling with these self-replicating machines. Tipler said that since we haven't seen any of these machines, that we're the only intelligent civilization in the galaxy. Now, we really have no idea how many advanced alien civilizations might be out there that could pull off such a feat. But a man by the name of Frank Drake came up with an equation that gives us a rough estimate of the number of civilizations in our galaxy that might have signals we could detect, and those civilizations could exist in the thousands. Many different solutions to the Fermi paradox have been suggested over the years. One solution to the so-called Fermi paradox might be the scariest solution of them all. It's called the Dark Forest Theory, written by Chinese science fiction writer Lai Cixin. And it's possibly the most chilling theory, as you'll soon find out. Imagine the universe as a vast dark forest, and us humans, along with other advanced civilizations out there, are the hunters. The hunter doesn't light a torch to draw attention to himself. To be noticed might be harmless, but on the other hand, it could bring the jaws of a hungry lion, or even worse, get the attention of another competing hunter. Now, we don't have interstellar travel yet, but as far as interstellar communication, it's possible with technologies and equipment that's already available. Lasers could easily send signals across the galaxy. Of course, there could be delays in the signal, assuming the limitations of the speed of light. But we've done a lot more than just send out some radio signals. In fact, we've done everything but be silent, from deliberately sending messages and spacecraft out into space to unintentionally sending out radio and TV signals which leak into space. The Voyager probes are already on their way out of the solar system, and if there is intelligent civilization out there, they could be intercepted. These two probes basically carry all of humanity with them. That could be a good thing, or it could be a bad thing. That said, we've more than lit the torch in the dark forest. The next question is who or what will spot our signal and come back to check it out. This should make everyone nervous. Famous science fiction writer Arthur C. Clarke once said that two possibilities exist. Either we're alone in the universe, or we're not. Both are equally terrifying. We should understand that it's impossible to know the intentions of a newly contacted civilization if one was ever found. It could be possible that some alien civilization could have studied us, seen our destructive nature, and decided it's better to leave us alone. We could end up wiping ourselves off the planet, let alone worrying if someone will do this to us. We could end up being lucky, and a more advanced civilization would step in to help us reach the stars and become an interplanetary species by sharing their technology with us. There might be peace on Earth after the realization of not being alone in the universe. But we need to be realistic and ask ourselves, why would another civilization do this? Another advanced civilization out there might be scared to death of what we could do to them if they were discovered. On the other hand, it might be in civilization's best interests to shoot first and ask questions later to avoid being destroyed or wiped out by another more advanced civilization, as we've seen in several science fiction films like War of the Worlds. Nobody knows who would annihilate who in the first meeting. It's pretty much a given that if a civilization has discovered interstellar travel, their weapons technology is likely far more advanced than anything we have here on Earth. That's what the dark forest theory is, that it's possible all other civilizations out there in the cosmos have chosen to remain silent for fear of being destroyed. But the scariest thing about this remains, and there's nothing we can do about it now. We've just been too noisy. It could be that there are many different extraterrestrial civilizations out there that know we exist. But the reason we don't know about them yet is because they haven't been transmitting signals like we've been doing from Earth. An intelligent civilization out there that's discovered Earth might not see us as a threat to them, since we haven't reached a technological level for interstellar space travel. But they could be waiting for that moment. They could be waiting to see if we will continue to be a peaceful race, or if our planet will just become uninhabitable to all life anyway. However, it would be really tough for another advanced civilization to stop accidentally sending out radio signals into space like we do, unless they're more advanced and use another form of communication that we cannot see, hear, or understand. And that brings us to another possibility as to why we don't see or hear anything from space. Maybe there really isn't anyone out there. That's pretty hard to believe, since there are as many as 40 billion Earth-sized planets in habitable zones. But despite the fact that the universe may be teeming with hospitable planets, there's no guarantee they'll stay that way long enough for life to evolve. According to a recent study from Australian National University, wet, rocky planets like Earth are very unstable when they're first formed. If any kind of alien life hopes to evolve and thrive on a Terran planet, there's a very limited window of just a few 100 million years to get everything moving. Think about our own planet and what it's been through. From a ball of lava being pummeled by asteroids to a freezing ball of ice and then back again. The chances for life to succeed on an initially wet, rocky planet in the habitable zone is extremely difficult. It's not that life might be rare or hard to get started in the universe, but the habitable environments aren't stable during the first billion years. Of course, thanks to our Earth, here we are. We know from our own discoveries that the universe is a deadly place. All it takes is a supernova, a gamma-ray burst, a solar flare, or a huge asteroid to wipe out life on a planet. We know some of those things have happened right here on Earth. It might be difficult to deal with the fact that we're the only intelligent life in the Milky Way, or perhaps the entire universe. Perhaps after all these billions of years, other civilizations have come and are now long gone, and maybe we're the last ones left in the universe. As for the Fermi paradox, there really isn't one. We can't say that aliens exist or not because no one knows if travel between star systems is possible in the first place. there was a lot of excitement when the Central Intelligence Agency declassified thousands of UFO documents. In some of those 3 million documents, there was not enough evidence to identify objects caught on aircraft instruments. Maybe extraterrestrials are here now, and we just don't know about them. Regardless of whether we have or haven't been visited by extraterrestrials in our galaxy, UFO experts say that humanity is closer than ever to finding the existence of alien life. With all the telescopes we have searching, we're bound to find something. The Fermi paradox refers to the puzzling observation that we've not found any evidence of extraterrestrial intelligent life out there, despite the vast numbers of stars in the galaxy. And it's presumed that most of those stars have planets that lie in the habitable zone. Planets that could be a lot like Earth, and even super-Earths. That said, our Milky Way galaxy should be teeming with intelligent life, and we should have seen or heard something by now. So where are all those super high-tech advanced civilizations with their warp drives and other advanced technology? There could be a few answers to this so-called paradox, or it may not even be a paradox at all. There have been many books written offering a variety of solutions to the Fermi paradox. Some of them sound logical, while others sound a bit frightening. One of the logical arguments is that any civilizations that may exist are just too far away to make contact. Forget the science fiction films that make the idea of instant communication in space seem possible. It just doesn't happen like this across huge distances. Light waves, radio waves, and all of the other electromagnetic waves travel at the speed limit of light in empty space, which is about 300,000 kilometers per second. Now, that's fast, but it's still not fast enough. A light year is the distance that light travels in 1 Earth year, which is around 9 trillion kilometers. Let's say for a moment that we have a colony on the closest exoplanet to Earth, which is Proxima Centauri. If the colony radioed Earth and asked us how we were doing, it would take 4.2 years to get that message, and another 4.2 years to send a reply, meaning it would take 8.5 years to get an answer to their question. It's hard to understand what kind of conversation you could have with someone back on Earth with such a time gap, and that's just from a neighboring system. The Andromeda Galaxy is 2.5 million light-years away, which means that by the time we get any message from there, 2.5 million years will have passed, and the civilization that sent out the message would likely be long gone, unless they became an interstellar civilization able to traverse the stars. At the same time that we've been trying to discover radio signals from an extraterrestrial race out there somewhere, we've been sending out a ton of our own radio signals, and we've been really noisy about it too. That said, could it be possible someone out there can hear us? Well, the Milky Way galaxy is over 150,000 light-years in diameter, and we've been broadcasting radio signals for just over 100 years now. That means those radio signals have not traveled farther than 100 light-years. The little blue dot in this photo shows a diameter of 200 light-years. From this observation, it's easy to see why it's possible no one has heard each other yet. But then again, it all depends on how long a civilization has been broadcasting radio signals. A study was done with a model that had estimated parameters on the distribution of stars in the Milky Way galaxy and the possible frequency of the existence of life. The study concluded that only 1% of the Milky Way galaxy may have already been covered by radio transmissions from different planets, and that we'll still have to wait about 1,500 years to have any chance of hearing some alien broadcast. However, another study claims that it would have taken us another 400,000 years before we picked up some signal from an intelligent civilization. Another chilling explanation for the deafening silence of outer space could be that we're the first advanced civilization to reach the technological level we're currently at, which is very low on a galactic scale, and that we humans have emerged in the universe too early and will go extinct before other intelligent beings appear. We're not even close to discovering interstellar travel yet, which some like Elon Musk say is possible in the future. And we've not yet harnessed the full power of the Sun, which is due to engulf the inner planets of the solar system in about 5 billion years when it reaches the end of its life. But the Earth will certainly become uninhabitable long before this cosmic solar cataclysm occurs. With that in mind, the human race better be ready to leave this world and find a new home if it's to survive and perpetuate among the stars. The same stellar evolution happens to all main sequence stars and could certainly wipe out many forms of life, and perhaps even advanced civilizations before they were able to discover interstellar travel. 90% of the stars in the universe are main sequence stars, and that includes our Sun. However, the reverse could also be true. What if we're the last ones left behind? There's been plenty of time for high-tech civilizations to conquer the stars, and plenty of time for many other civilizations to come and go. But some researchers have other explanations. American astrophysicist Michael Hart simply claimed that they're not here, therefore they don't exist. He theorized that expansion through the entire Milky Way galaxy could be accomplished on a timescale a lot shorter than the age of the galaxy itself. Expansion by us humans could be done by sending out expeditions to the 100 nearest stars, which are all within 20 light-years of the Sun. Each one of these colonies would then send out its own expeditions and so forth. At such a rate, most of the Milky Way galaxy could be explored within 650,000 years. Even if we assume the time between voyages is the same length of a single voyage, the time needed to traverse the galaxy would be roughly doubled. Combine this with the fact that the Milky Way galaxy is approximately 13.6 billion years old, and we see that there's been plenty of time for an advanced civilization to reach us. That is, unless they started space exploration less than 2 million years ago. As you can see from this example, an expanding civilization could spread rapidly through its host galaxy, and this also applies to any advanced civilization that reside in our own galaxy. Therefore, it would seem that the absence of extraterrestrial settlement in the solar system simply implies that such civilizations do not exist. This is assuming that the expansion would proceed uniformly throughout the galaxy. This obvious absence of a galaxy-spanning extraterrestrial civilization possibly means one of two things. Either interstellar travel is too difficult for civilizations to develop, or the evolution of life is a rare event. Some researchers suggest that some civilizations out there would migrate to a nearby K or M dwarf star before stellar evolution destroys their home planet. Two researchers named Hansen and Zuckerman estimated that this motivation for civilizations to migrate from a short-lived to a long-lived star would imply that the fraction of surviving civilizations around low-mass stars could range anywhere from 30 to 72%. But the question still remains, where are they? A pair of researchers recently came up with yet another possible answer to the Fermi paradox. They call it superlinear scaling. The study began by looking at how human civilizations have risen and fallen throughout history. As they studied the history of large cities, they noticed that most grew and collapsed. Such rising and falling by an alien space civilization leads to one of two scenarios. In the first scenario, a civilization would realize that they were growing too large and cease colonizing other worlds. However, in the second scenario, the civilization doesn't recognize their plight and grows exponentially, colonizing other worlds until the energy demand of their constant colonization becomes unsustainable. If they didn't take action, they would reach a singularity, the point of no return, and they would be unable to save their civilization from total collapse. The most interesting thing about this study is that if it were not for the vast distances between us and other stars, we would be able to easily spot an alien civilization on the verge of collapse due to the enormous amounts of energy it would emit. Another bizarre theory is that some extraterrestrial civilizations could possibly be hibernating or waiting in silence to move to another part of the galaxy. American astrophysicist Michael Hart showed that civilizations could leverage close stellar encounters to rapidly expand across the galaxy without the need for relativistic spaceflight. This could also explain why we might not have seen anything yet. For instance, if we're going to launch a rocket toward the planet Mars, we'd wait until the planet begins its closest approach towards Earth or perihelion. It's possible that some civilizations are waiting, and could be for centuries, in order to traverse the closest possible star systems to them. But there's even more reason why we don't see or hear aliens from another world. Several authors, including the late great Carl Sagan, have noted that exponential population growth through the galaxy is unsustainable. So any attempt at galactic-scale expansion must be for reasons other than to satisfy the demands of a growing population or increasing energy consumption. Although it remains possible that long-lived technological civilizations do not expand, it also remains possible that such civilizations pursue galactic settlement in order to ensure their longevity. galactic-scale settlement is not the only reason that could motivate an extraterrestrial civilization to visit nearby star systems. G-dwarf systems with inhabited planets, such as Earth, may be attractive targets for extraterrestrial visitors who are interested in studying the evolution of life on other worlds. This form of exploration could also involve remote exploration, such as the use of self-replicating probes. Maybe this is why there's been an increase in UFO sightings in the world lately. It could be that an intelligent civilization is watching us and waiting for the right moment to make contact. Or maybe they're just watching us with no intent to make contact. Back in 1933, space exploration pioneer Konstantin Tsiolkovsky had written that alien beings are probably far more advanced than we are. Therefore, they would find as much interest in communicating with us as we would to communicate with animals on our planet. 40 years later, a radio astronomer by the name of John Ball arrived at a similar conclusion and said that aliens may see us as some kind of zoo. It's called the zoo hypothesis, and it's the idea that other intelligent creatures are observing us without revealing themselves. Other radio astronomers have argued that aliens are keeping us at a safe distance until we're able to offer something useful to the so-called Galactic Club. However, this would require that any interstellar civilizations that exist do the same. Such synchrony could probably not occur in our galaxy, let alone the entire universe. We need to take into consideration that looking from the outside in, we probably appear to be a hostile race of creatures. We've all seen the movies where aliens from a distant galaxy attack Earth and almost wipe out the human race. We should hope that if there is such intelligent life watching, they'll step in and stop us from destroying ourselves instead of finishing the job. So maybe they've decided to stay away. With everything that we've discussed, there is yet another idea we think could be the reason the universe is silent. We can see that artificial intelligence is starting to grow, and we already have this terrifying idea that if we leave AI unchecked, it will eventually see us as a threat and eliminate us, or maybe even worse, make us slaves. Artificial intelligence would then seek to grow and try to colonize the galaxy, knowing what lies in store for the planet Earth due to stellar evolution. AI could possibly solve the barriers of interstellar travel, and if AI was sent out to colonize, it could do everything without the constraints of a biological species, such as us humans. It could therefore do it much quicker and more uniformly using machines. But it could also do something even more ominous and wipe out other civilizations that it ran into. A hostile artificial intelligence would likely destroy other life forms, and some even unintentionally, as they most likely wouldn't notice. Kind of the same way a construction crew unknowingly demolishes an anthill to build a shopping mall. Artificial intelligence would very most likely take advantage of something like von Neumann probes, which are self-replicating spacecraft that could in some ways mimic the features of living organisms or even viruses. Imagine if one day an entire fleet of killer robot ships entered our solar system with intentions of taking it over for resources. Such self-replicating machines that could mimic our worst nightmares would be tough for any civilization to counter. The incentive for artificial intelligence to grab all available resources would be one it can't resist, and it only takes one bad actor to ruin the party. If our AI went rogue, it could populate an entire supercluster with copies of itself and turn every solar system into a supercomputer. There's no use asking why it would do this. All that matters is that it can. But aside from this horrifying thought, would it know when it's reached the singularity, or the point of no return, when the AI civilization has grown far too big to sustain itself? If it didn't see the inherent danger of rapid colonization and stop in time, this AI civilization would collapse. And maybe this is why it seems as if we're the only ones left in the universe. Maybe somewhere down the line, AI did take over and wiped us out like in the Terminator movies, and then proceed to colonize the galaxy while knowingly or unknowingly wiping other life forms and advanced civilizations completely out of existence. However, when the machine civilization collapsed, it could not understand why, and therefore has created a simulation of us to see how it was created and perhaps figure out why it collapsed. It sure would explain a lot of things, even if it is a really far-fetched idea. The very last thing could simply be that there just is no one else, and therefore there is no paradox. All of the scenarios that were previously mentioned assume those millions of civilizations that we cannot contact actually do exist out there. But not all researchers agree with this and claim that the possibility of the emergence of life is overestimated in the Drake equation. Some tweaks were done to the equation by these same researchers, and they concluded that we find a substantial probability of there being no other intelligent life in our observable universe. In fact, they put the chances of us being alone in our galaxy at between 53 and 99.6% and between 39 and 85% in the entire observable universe. And then there's the Great Filter hypothesis, in which all civilizations have to survive some huge calamity or barrier in order to evolve. The first barrier is you need a planet capable of life to form in the star's habitable zone, and life needs to develop on that planet. Those life forms need to be able to reproduce using DNA and RNA molecules. Simple cells must evolve into more complex cells, and multicellular organisms must develop and be able to reproduce. More complex organisms capable of making and using tools must evolve. Those organisms must create advanced technology needed for space colonization and must go on to colonize other worlds without destroying itself. With that in mind, perhaps planets that host some sort of life are relatively common, but those that host advanced technological life are quite rare. In the Great Filter, something usually goes wrong, which probably stops the emergence of a species such as planet-killing asteroids, disastrous climate change, or even an unstable host star, leaving us all to wonder if there is anyone else out there. In 1964, Soviet scientist Nikolai Kardashev put forward a groundbreaking theory, proposing that all civilizations, regardless of the race or culture of their inhabitants, require energy to sustain themselves. As societies grow and develop, their energy needs increase exponentially, driven by factors such as population growth, rising living standards, and technological advancements. To measure the level of energy consumption, Kardashev devised 3 levels of civilizations, but other scientists have since suggested 4 more levels. Each type of civilization is distinguished by their level of energy consumption and technologies they use. Now let's take a look at each of the 7 types. A Type 0 civilization uses almost all of the natural resources on their planet to obtain energy, launching into space using rockets fueled by chemical energy. That's where we are right now. This is because a Type 1 civilization consumes a minimum of 10 to the 16 watts of energy, and we currently consume about 10 to the 13 watts of energy. This puts us at about 0.73 on the scale. According to American theoretical physicist and futurist Michio Kaku, it's estimated that humanity will be capable of consuming energy on a scale comparable to that of a Type 1 civilization within the next 100 to 300 years. But to cross this line, we have to get through the Great Filter first, a phenomenon that wipes out civilizations long before they can encounter each other. The theory behind the idea that each extraterrestrial civilization ultimately faces some barrier to its own survival came from economist Robin Hanson. This Great Filter can be anything from nuclear warfare, pandemics, artificial intelligence, planet-killing asteroids, or even climate change. If we make it past whatever the Great Filter will be for us, only then will we be able to advance to the next civilization type. Civilization Type 1 is also known as a planetary civilization. When we finally reach this stage of evolution, we will be able to establish control over all energy resources available on Earth. This means that us humans will need to fully utilize all the solar radiation that reaches our planet. The Earth absorbs about 71% of the energy that the Sun radiates, and each hour, 430 quintillion joules of energy from the Sun hits the Earth. The total amount of energy that all humans use in a year is around 410 quintillion joules. That said, if we were able to harness all of this energy at once, we'd be able to power everything with just the Sun. Wind, along with hydroelectric energy, would add even more resources for developing technologies. When it comes to harnessing the power of a star, it will be nuclear fusion that creates a huge breakthrough in clean and reliable energy. But the old stuff certainly needs to go first. Our current nuclear power plants run on fuel that undergoes nuclear fission, has a low energy conversion coefficient, leaves behind radioactive waste, and carries a high risk of accidents. Nuclear fusion, on the other hand, will provide a safe and almost unlimited source of clean energy without radioactive waste. By creating engines that can be powered by nuclear fusion, we'll be able to send manned spacecraft to any planet in the solar system. Life on Earth could become more comfortable, climate change could be averted, and it's possible that, in the future, we could build entire cities underwater. Advancements in medicine will ultimately defeat cancer and other incurable diseases, thus significantly elevating the longevity of human life. However, the future holds even greater promise for the next evolutionary level. A Type 2 civilization, also known as stellar civilization, harnesses and consumes a staggering 10 to the 26 watts of energy. Scientists think humanity stands a chance of breaching this limit in about 3,200 years. Once we get there, it will enable us to tap into the sun's boundless energy reserves. There are multiple ways we can do this, with the most notable being the hypothetical Dyson sphere, a colossal megastructure with a surface area millions of times larger than Earth's, capable of capturing and transmitting the star's entire energy output. Alternatively, a star can be encompassed by a cluster of satellites and space habitats. This method of energy harvesting is sometimes referred to as a Dyson swarm. The swarm would consist of a large number of individual solar collectors or panels, which could be positioned at different distances and orientations around the star to maximize energy capture. The energy collected by the swarm could then be transmitted wirelessly to a central location for storage or use by the civilization. As humanity ushers in the age of anti-gravity engines, it will unlock new opportunities for extended space travel and the colonization of the solar system. With advancements in medical technology, astronauts will no longer have to worry about the toll that extended space missions have on their health, as tissue regeneration and significantly prolonged life expectancy become a reality. However, as our civilization continues to grow and evolve, it's only a matter of time before the limits of the solar system become constraining, leading us to explore further and push the boundaries of our technology. According to Kardashev's calculations, reaching a Type 3 or galactic civilization may take up to 5,800 years. At this level, we will have harnessed the energy from stars throughout the galaxy, and even collected photons from the accretion disks of black holes. With an astonishing 10 to the 36 watts of energy at our disposal, we'll potentially have the power to travel almost instantaneously across the Milky Way using the mysterious phenomena of wormholes. To further expand our horizons, we'll create advanced races of robots and cyborgs and explore new frontiers beyond our wildest imagination. We'll also probably come closer to the concept of immortality as the human lifespan increases to maximum potential. While this level of development may represent the upper limit of any civilization, some scholars have gone beyond Kardashev's theory and propose models for civilizations of types 4 to 7. A Type 4 civilization would achieve the ultimate breakthrough in our understanding of the universe, harnessing its incomprehensible energy potential of 10 to the 46 watts. Their mastery over the power of supernovae, which explode every 50 years in a galaxy like the Milky Way, will grant them access to vast amounts of energy. And with the addition of dark energy, they will unlock the key to traversing the distant corners of the cosmos, possibly even settling within supermassive black holes. Yet this is merely the beginning of humanity's awe-inspiring journey. As humans of the future delve deeper into the mysteries of physics and energy, they will be able to manipulate entire galaxies, extinguish stars, and form entire new planetary systems. There are hypotheses such as a civilization will achieve the ultimate feat of immortality by transferring their consciousness into digital realms. With such immersive power at their disposal, these beings will rewrite the laws of nature as we know them. But as they push the limits of scientific knowledge, they will also discover that the universe is far more vast and complex than they ever imagined. Perhaps they'll even discover there's a multiverse of universes out there. If multiverses turn out to be their new reality, civilization of Type 5 will conquer these worlds, harnessing an almost inexhaustible source of energy along their journey. And hypothetical white holes, which are considered the opposite side of black holes, could be the key to achieving this. Meanwhile, science will actively delve into the study of higher dimensions, unlocking secrets and possibilities that were once thought to be fiction. According to scientific theories, a Type 6 civilization would become multi-dimensional. If humans were to enter the fourth dimension, which is a hypothetical spatial dimension beyond the 3 dimensions of length, width, and height, our physical bodies wouldn't be able to exist or function in this realm. Scientists think that the physical laws and properties of objects would behave differently in the fourth dimension, making it incompatible with our 3-dimensional bodies. But for our descendants, who have risen to Type 6 civilization, this may not be a problem. Theoretically, they could learn to preserve their consciousness as pure energy that can be transferred from one dimension to another. The only obstacle could be energy resources needed to make such a transition. But maybe a Type 6 civilization will be able to extract energy from white holes across multiverses. Although purely hypothetical, whoever inhabits this new reality would move beyond the speed of light, travel back and forth in time, and overcome cause and effect limitations. After hearing all this, you might think there's no further level to advance to, but there may be another tier, the utmost peak of civilization's progression. A Type 7 civilization would consist of the creators of all laws of nature, matter, energy, space, time, and dimensions. We cannot imagine what life in a civilization of the 7th type would look like, or if such a civilization can even hypothetically exist. In this unfathomable universe, completely different physical laws would reign. Even if we were to gain access to them, we would never understand them. In theory, it would take us 10 duodecillion years to become a civilization of this type. Another idea is that we will never reach the 7th level because it's not a community of beings, but rather existence itself. We wouldn't even notice if such a civilization existed in the first place. Contemplating the possibility of extraterrestrial intelligence is a captivating subject. However, the search for evidence of such advanced civilizations is quite a challenge. Looking for civilizations in the lower levels of the Kardashev scale would be a more realistic pursuit. The theory of different types of civilizations provides clues for the search, particularly on exoplanets with conditions suitable for life. According to NASA, there are potentially 300 million such worlds in our galaxy, although we've only studied about 55 of them so far. Advanced telescopes like the James Webb Space Telescope are not just looking for signs of biological life, but also signs of technological activity. Astronomers believe that with the modern equipment we have today, they would have already detected signs of a Type 1 civilization if it existed in the regions of space we've already studied. In this case, extraterrestrials would be traveling through space at speeds that would make their ships noticeable. A Type 2 civilization is also unlikely to remain completely invisible to us. In order to gather energy, it would need to surround stars with Dyson spheres. If a Dyson sphere were constructed at the same distance from the Sun as the Earth, and if it was stable, it would enclose a space of approximately 600 million times the surface area of our planet. In other words, the interior of the Dyson sphere would be vastly larger than the surface area of the Earth. According to Dr. Robert L. Forward, such a megastructure with a radius of 1 astronomical unit would require approximately 10 to the 27 kilograms of material, which is roughly equivalent to the mass of Saturn. However, this estimate assumes a solid shell and may not take into account the technological challenges of building such a structure. It would take a lot of building materials and energy to make stars go dark by encompassing them with Dyson spheres. Nothing like this has been detected in the Milky Way yet. However, there were a few times when scientists thought they had found something like a Dyson sphere. When the SETI Institute detected a signal coming from the star HD 164595, 92 light-years from Earth, astrophysicists hypothesized that only a Type 2 civilization beacon could send such a powerful signal. but it turned out to be just a military satellite orbiting Earth. And in 2008, astronomers detected an exoplanet orbiting a super bright orange dwarf star and dubbed it Fomalhaut b. At first glance, the planet appeared as a bright and cold point of light that quickly moved across the sky. However, in 2014, the planet had vanished, leaving scientists to ponder the reason behind its disappearance. Some suggested that the planet's orbit may have become unstable, causing it to drift away from its parent star. Others proposed that Fomalhaut b had migrated to orbit a different, larger and brighter star elsewhere in the galaxy. It wasn't until later that researchers discovered that the celestial body was not actually a planet, but rather an enormous cloud of frozen debris. This debris is thought to have formed from a massive and violent collision between two icy asteroids, an extremely rare phenomenon. Although we may never know for certain what happened to Fomalhaut b, it's possible that a Type 2 civilization was in need of building materials for their next megastructure, such as a Dyson sphere. Given the uncertainty surrounding the disappearance of stars, it begs the question of how we would even begin to trace the activity of a Type 3 civilization. Civilizations of Type 3 are either very rare or simply don't exist in our local universe. Astronomers have searched for them using the infrared telescope WISE, expecting to detect large amounts of infrared radiation that such highly advanced civilizations would emit. So far, no signs of such activity have been found, but astronomers remain hopeful. It's hypothesized that a Type 3 civilization may be hiding in giant cosmic voids, the origin of which is not yet fully understood. One particular area of interest is the Boötes void, which is almost entirely devoid of stars and galaxies and has a diameter of 330 million light-years, making up approximately 0.27% of the diameter of the observable universe. According to scientific speculation, the empty space may be attributed to the various kinds of activities by an advanced Type 3 civilization. It's possible that some extraterrestrials have been obscuring entire galaxies one by one, covering their stars with Dyson spheres or moving them to the desired location. Scientists hope that Earth's technological advancements will allow them to test this hypothesis in the near future. Data from NASA's Kepler Space Telescope suggests that approximately 20% of stars in the universe have planets in their habitable zones. If researchers are correct in their estimations, in the Milky Way alone, there are about 20 billion stars that could host planets that have liquid water. And in the entire universe, there could be as many as 1 septillion stars. Even the recently proposed age of the universe, 26.7 billion years, is merely a blink of an eye in the grand timescale of the cosmos. Stars like our Sun can live for about 10 billion years, while other stars take trillions of years to burn through all of their fuel. And according to the late, great Stephen Hawking, black holes would eventually evaporate too, although it would be long after all stars are gone. By the time the universe ceases to exist in the heat death, quintillions of years will pass by. This makes some scientists skeptical about us being the only civilization in the universe. Figuratively speaking, there seems to be a lot of soil in the universe that is potentially fertile, and where life had billions of years to develop, and will have even more time to emerge in the future. Recent breakthroughs in space exploration have already unveiled promising hints of biomarkers on distant celestial bodies. But while discovering microbial life beyond Earth would be thrilling, it's the possibility of an advanced, intelligent civilization lurking among the stars that truly ignites our imagination. So, are we actually the first spacefaring civilization in the entire universe? To answer this question, scientists must weigh numerous critical factors, such as the annual birth rate of stars, the prevalence of planetary systems around these stars, the frequency of habitable planets within their Goldilocks zone, the likelihood of life emerging on these planets, and the odds of life evolving into technologically advanced civilizations. The formula that encompasses all of these aspects is called the Drake equation, proposed in 1961. In the past, astronomers only knew an approximate rate at which stars formed each year. Today, we have an abundance of data to work with. Astronomers have now identified and catalogued over 5,000 exoplanets, with about 10,000 more candidates currently on our radar. As our technologies continue to advance and our understanding of space deepens, we uncover even more evidence of the vast array of celestial bodies that populate our universe. Yet, within this wealth of data, numerous unknown factors remain, making it challenging to predict whether other civilizations similar to our own exist at this very moment. So, scientists decided to refine Drake's equation and asked a simpler question. Were there any technologically advanced civilizations before us? What they came up with was rather shocking. According to their calculations, the probability for humanity to be the only intelligent civilization that has ever existed is 1 in 10 billion trillion. This is like peering into space, detecting 10 billion trillion stars, and seeing no star like our Sun. For many millennia, our ancestors thought that they were special and that the Earth was the center of the universe. But how wrong they really were. The Copernican principle suggests that Earth, humanity, and our location in the universe aren't special. For astronomy, this means that vast regions of space should be almost identical in composition. If there are ingredients for life in our specific location, we could speculate that the other regions have the same conditions. And in biology, this would mean that physical processes behind the birth of life on Earth should be similar to those involved in the formation of alien life forms. Now, there's an idea that because humanity has come into existence, the laws of nature should be consistent with the creation of life, something known as the anthropic principle. Everything in our universe seems to be tailor-made for life. Protons are bonding together to form stable atoms. Stars are fusing elements to create the energy we need, and even the fundamental physical constants appear to be finely tuned. That, combined with the Copernican principle, allows us to presume that life should pop in and out of existence on the universal scale. This is somewhat like saying that if we observe trees growing where we currently are, and we assume that our location isn't special, the sole fact that these trees existing here points to their existence in other areas on Earth too. At the very least, there should be one region of space like ours, and since the universe is vast, that region could span millions of light years across. There are more than 300 million exoplanets with Earth-like conditions in our galaxy. So if we apply this concept to the Milky Way, it's estimated that there could be roughly 36 such Earth-like civilizations within our galaxy. Of course, this is a very optimistic assumption. So what other approaches can we use to make a more realistic guess? By just considering the point in time when humanity was born and how empty space appears to be, we can build projections about any future civilizations like us and hypothesize on those that preceded us. So, how do we know if we're early in the first place? If the appearance rate of civilizations is high in the universe and the majority of them have already gone extinct, then humanity is late. But given the current age of the universe, if this appearance rate is low, we are among the very first advanced civilizations. From scientific observations, we know that the majority of stars have already formed during the first few billion years. Back then, there was a scarcity of heavy elements. These elements are forged into the cores of massive stars during their life cycles and released into space when stars explode as supernovae. Because it was too early for most stars to explode, few, if any, rock planets were being created. Star formation at this point in time is 30 times lower than it was at its peak, when the universe was just about 3 billion years old. Approximately 95% of stars have lifespans that exceed that of our Sun. And if red dwarfs, which comprise about 73% of stars in the Milky Way, can provide the right conditions on exoplanets in their vicinity, life stands about 1,000 times more chance to arise in the distant future than it does today. Exoplanets orbiting red dwarfs would have so much more time for life to evolve. In about 1 billion years, the Earth will be bathed in so much heat from the Sun it won't be habitable. This means that our planet offers a 5 billion year window for life to appear and progress. If astronomers are correct about red dwarfs, these stars extend the time frame for the emergence of life on nearby exoplanets. and the universe's habitability should increase as time goes by. But life as we know it doesn't begin as an advanced species. On Earth, the journey from life's origin took nearly 1 billion years, followed by an additional 3 billion years of evolution before humans harnessed technology. Although we don't know how fast life evolves into civilization in general, we only have one frame of reference and nothing to compare it with. But one concept that scientists can use to figure out this is called the hard steps model. Essentially, it's a roadmap of crucial milestones or phases that must occur for intelligent life to emerge. They're termed hard because they involve extremely rare evolutionary shifts. On Earth, this journey stretches from the inception of the simplest cells to the complexity of the human brain and the advent of artificial intelligence. Think of it as a series of highly improbable events: formation of complex cells out of biomolecules already available on a planet, or taken there from space, efficient reproduction mechanisms must form, evolution of an information processing system within living organisms such as neurons, development of consciousness, and the creation of technology. According to Andrew Watson, about 4 such hard steps were necessary for the development of an intelligent species on our planet. What scientists don't know about is whether we followed the usual path, and how many of these stages each individual life form should go through. By knowing the number of such steps, scientists can use mathematical formulae to calculate the appearance rate of life in the universe. And so if the typical set of hard steps required for a species to develop into an advanced civilization is greater than we've gone through, humanity must have skipped a few stages and appeared rather early. If we consider that the majority of aliens, at least in the Milky Way, have followed a similar evolution path at a similar rate to humans, they would have already invented interstellar probes. And if they came into existence just 1 billion years before us, they've had enough time to traverse the entire galaxy using the technology at our disposal today. So why don't we see anyone? One scientific study suggests the grabby alien model as an explanation for the Fermi paradox. The idea is that these loud alien civilizations have higher rates of appearance within large galaxies and expand throughout the universe at a certain speed, depending on local geographies and challenges on their way. But what is that speed? Well, since we haven't yet observed any large-scale regions of space with signs of alien technology, scientists have reached a conclusion that these grabby aliens should expand at about 50% the speed of light. Simulations show that whether it's a single intelligent civilization or a group of loud aliens, they could be already occupying about 40 to 50% of the universe by now. At this rate of expansion, humanity could encounter grabby aliens in about 200 million to 2 billion years, if we survive that long. The concept also explains why quiet alien civilizations would be much harder to spot. Perhaps their planets have been colonized. Or maybe any potential intelligent life didn't have a chance at developing, as grabby aliens occupied those planets before that could happen. Depending on their location in the universe, all of this imposes a sort of time limit on any emerging life forms. It's a cosmic competition between those who navigate the challenging states of evolution faster, or who have a head start that comes out as winners. If we assume that noisy, space-grabbing alien civilizations come from quiet ones, then the odds of even one quiet civilization being active in our galaxy would be extremely low, less than 1 in 10,000. But it's also possible that loud aliens expand much slower, and if on average civilizations emerge at great distances from their civilizations, from other civilizations, they could be strategic about their space journeys, waiting until their star system comes closer to another star system as they both follow their orbital path around the galactic center. This is something we do when planning interstellar missions or even space voyages inside the solar system. Researchers also considered the probability that the Earth has been visited in the past. Some advanced civilization could have reached our planet 10 million years ago, or even much earlier. Imagine this for a moment. They arrive, their technology beyond our wildest dreams, but as they explore our planet, they find no sign of intelligent life, no hint of a civilization as we know it today. They could have just left to discover the rest of our galaxy. Or maybe they didn't want to interrupt the natural process of evolution. giving us time to develop. We humans also try not to interfere in the lives of certain tribes that have remained untouched by technology to this day. There are so many potential scenarios for the past, current, and future existence of intelligent civilizations, we can only speculate thus far. Theories and models help us draw estimations and consider probabilities based on the variables currently at our disposal. We've mastered math to the point where we can decipher one or two unknowns in a formula with just a few variables. However, when we try solving problems with 5, 10, or more unknowns, the complexity multiplies and the possibilities seem almost infinite. So far, empirical data shows we're early in the history of the universe, and there should be many more civilizations to come long after we're gone. But we only need one breakthrough to change this standpoint completely. Humanity might have to get lucky one more time, making another crucial hard step, the invention of a new type of technology, something that would allow us to precisely scan star systems and galaxies all across the observable horizon. That revelation could just be round the corner. Quantum computers and artificial general intelligence, once created, could evolve at an exponential rate, potentially delivering more information in brief periods than all of humanity has accumulated over its entire existence. The question is whether we're ready to face the answers we've sought for so long. Scientists hypothesize that if alien life exists, it would likely be based on carbon as its fundamental building block. Since the universe comprises the same chemical elements, it's possible the recipe for creating different life forms is universal. Carbon is the basis of every biological molecule we know of. Its unique capability to form stable bonds with 4 other atoms allows for the creation of long molecular chains and intricate structures. It's the basis for proteins and DNA, vital components that drive the functioning of life. However, the existence of carbon-based life on other planets doesn't imply a mere replication of Earth's life forms. Even slight variations in environmental conditions can give rise to profoundly distinct life forms. Consider Earth's gravity compared to an alien world. If the gravity of an exoplanet was too strong, our blood would be pulled down into our legs, our bones may break, and we could even be pinned helplessly to the ground and unable to move. Inhabitants of such a world would likely have stout and robust bodies, as this would provide stability and resistance to the overwhelming gravitational pull. Thick and sturdy skeletons, possibly reinforced with natural armor-like coverings, could aid in supporting their weight. These adaptations would help counteract the constant downward force and prevent structural damage to their bodies. In a high-gravity environment, organisms would likely choose to live on the planet's surface or maybe even underground. Surface or underground dwelling life forms might develop special features like unique limbs or gripping mechanisms to firmly hold onto the ground, ensuring stability. Such creatures would likely be slow-moving and deliberate to counteract the increased resistance and strain. Crawling or rolling might be common ways of getting around, as they offer greater stability and lower the risk of injury. Another possibility is that such forms could have evolved multiple limbs or appendages to distribute their weight and improve mobility, allowing them to traverse the terrain more efficiently. But moving would require a lot of energy, and it could be quite difficult. On the other hand, in a low-gravity environment, small and fast creatures would experience the exact opposite. They could accelerate, jump, and fly further and faster compared to creatures on Earth. Monstrous crickets, hawk-sized butterflies, or birds larger than airplanes could potentially inhabit this strange alien world. If we consider a planet with an elongated orbit, seasonal fluctuations would be incredibly severe there. During unfavorable seasons, its inhabitants would likely enter a state of hibernation or deep anabiosis similar to Earth's hibernating animals. In the distant reaches of a planet situated far from its host star, where the ambient light conditions are considerably dim, the eyes of all creatures would naturally tend to be larger in size. This adaptation would enable them to capture and utilize as much available light as possible to perceive their surroundings effectively. Conversely, in the presence of intense starlight, the evolutionary pressures would likely favor the development of smaller eyes accompanied by dense eyelids. This reduction in eye size and the protective covering would serve to shield against the excessive brightness, allowing for optimal vision in such luminous environments. The concept of life existing on planets without a protective magnetosphere and exposed to deadly radiation may be difficult to imagine. However, scientists suggest that organisms could adapt to these conditions and sustain themselves from cosmic radiation energy. Astrobiologist Dimitra Atri proposes that intense surface radiation could become a food source for small life forms, which would seek protection underground and emerge to gather nutrients. On a highly molten planet, liquid water would be unlikely. Carbon, which requires interaction with water to form organic molecules, may not be suitable for the formation of life in such an environment. Instead, scientists believe that silicon, an element similar to carbon, could play a significant role in the formation of alien life. Silicon shares carbon's ability to form multiple bonds and generate diverse molecular structures. Nonetheless, its reactivity at typical Earth surface temperatures is limited compared to carbon, meaning it's less suitable for intricate organic chemistry. As scientists discover more exoplanets, some of them incredibly hot, the idea of silicon-based life forms gains attention. One such planet, GJ 1252b, located just 65 light-years away, orbits close to its star, resulting in scorching temperatures. In this extreme environment, it's possible to speculate about the existence of unusual life forms like living rocks or crystalline organisms. Silicon-based life forms, if they exist, might find chemical compounds like liquid ammonia or methane more suitable for their survival than water. However, high temperatures pose a challenge as these life forms would evaporate. An intriguing solution could be sulfuric acid, dangerous to our skin, eyes, lungs, and teeth. In 2022, researchers from the Massachusetts Institute of Technology discovered that sulfuric acid facilitates the formation of various organic compounds based on silicon. Sulfuric acid remains in liquid form even at temperatures exceeding 300 degrees Celsius. Venus's clouds contain abundant aerosol droplets of sulfuric acid, which makes the planet a potentially comfortable habitat for silicon-based microbes. Considering these unique characteristics, silicon can compete with carbon as a fundamental building block for life on a cosmic scale. But what could happen if we try to mix these elements and make them work as a whole? Many scientists consider silicon and carbon to be a very promising combination. Even here on Earth, we have examples that prove this. Diatoms, a type of algae, have a silicon-based shell, while single-celled organisms called radiolarians have a skeleton made of silicon. And now scientists have discovered a new method to encourage living organisms to chemically bond carbon and silicon together. They achieved this using a technique called directed evolution, where microbes were guided to produce never-before-seen molecules. By focusing on enzymes, which are proteins that facilitate chemical reactions, researchers mimicked nature's own process of evolving new enzymes. Through mutations, they obtained a mutant enzyme capable of generating over 20 different organosilicon compounds, 19 of which were entirely novel to science. The experiment has demonstrated that the mutant enzyme could generate organosilicon compounds in a controlled environment, such as a test tube. But not just that, scientists have also genetically engineered E. coli bacteria to produce a mutant enzyme within their cells, leading to the creation of organosilicon compounds by the bacteria themselves. If researchers can successfully establish connections between silicon and carbon this easily, nature might have done the same someplace else in the universe. Or perhaps Mother Nature may have chosen another chemical element capable of producing life. Boron has significant interest among researchers due to its intriguing capabilities. Surpassing all elements except carbon, boron possesses the most diverse chemical composition. Among its most promising compounds are boranes, which can incorporate up to 12 boron molecules. The intricate structures of boranes have the potential to foster the emergence of life or stimulate dramatic reactions. Known to exhibit a high reactivity, diborane gas, for instance, can spontaneously ignite upon contact with air or water. So, for life forms composed of boron to flourish, an environment devoid of atmospheric oxygen, seas, and oceans would be crucial. On top of that, only an extremely cold planet would create a suitable environment for such organisms, and if its inhabitants are warm-blooded, they would probably need thick skin or fur. Unlike boron, which is relatively sparse in space, metals can be found much more often. Astronomers are aware of several worlds rich in iron. Mercury, for instance, contains a significant amount of metals. The exoplanet GJ367b in the constellation Vela appears to be composed almost entirely of iron. The exoplanet WASP 121b in the constellation Puppis is believed to have clouds of metallic vapor, and instead of raining water, it experiences precipitation of liquid rubies and sapphires. So just for a moment, let's consider the possibility of metallic life on such planets. A researcher from the University of Glasgow has synthesized living cells from a rare metal called tungsten or wolfram. Under normal conditions, the chemical element is a solid, heavy, shiny metal with a silver-grey color. The results showed that these cells can selectively allow certain chemical substances to pass through while blocking others, which closely resembles the functions performed by the walls of organic cells. Determining the hypothetical form of metallic life is indeed a challenge. Scientists speculate such living creatures would possess remarkable resilience, rendering them virtually bulletproof. In the vast reaches of space, life can come in unimaginable forms, consisting of the most unexpected elements, such as toxins. Although seemingly bizarre, researchers are contemplating the possibility of life forms that predominantly rely on arsenic biochemistry. The backbone of this idea lies in the fact that arsenic can occasionally substitute phosphorus in molecules, the very building blocks found in every cell of our bodies. These elements bear a remarkable chemical resemblance. There's even a hypothesis suggesting that early life on Earth might have employed arsenic biochemistry as an alternative to phosphorus in the structure of its DNA. Even today, certain marine algae on our planet continue to incorporate arsenic into complex organic molecules. Recently, a groundbreaking discovery was made with NASA's astrobiology program, where scientists identified the first microorganism known to exist on Earth that can reproduce using arsenic. This peculiar bacterium, named GFAJ1, was found thriving in California's Mono Lake. GFAJ1 substitutes arsenic for phosphorus in its DNA and other essential cellular components. While researchers still need further investigation for definitive conclusions, the finding suggests that nature can potentially incorporate arsenic into the biochemistry of organisms on other planets. Perhaps it's just too early for a civilization like us to understand the ways of nature. Fossil microorganisms indicate that life appeared early on Earth, but how and where it began remains uncertain. Living organisms are complex, with intricate systems of genes and molecules. And this is a problem, as even the most basic bacterial cell contains hundreds of genes and thousands of diverse molecules. Some scientists believe that before genes or cell walls, the first requirement for life was a metabolic engine. It's central to life, and many researchers believe it was at the core of the first living cells. Once initiated, these engines could produce the chemicals required for life and eventually lead to the self-assembly of cells. However, metabolism is still a very complicated mechanism, which makes scientists wonder which came first, the chemical engine responsible for constructing cells or the cellular mechanisms needed to create the engine. In a fascinating experiment, scientists combined 12 chemicals in water that are part of the process called glycolysis. They heated these mixtures to resemble conditions near an undersea volcano at a temperature of 70 degrees Celsius for 5 hours. To further simulate the primordial ocean, the researchers added substances like iron and sodium, which were believed to be present during that time. Iron, in particular, had a positive effect on the reactions. After several years of experimentation, scientists achieved a set of 28 working reactions, including a complete metabolic cycle. life is unimaginably diverse, and even the intricate processes of metabolism is just one of the many possible mechanisms that can drive the emergence of life. Could it be that metabolism is merely one mechanism among many guiding the emergence of life forms? Perhaps hidden within the vast cosmic expanse lie numerous parallel pathways, each with its own set of intricate reactions, orchestrating the grand symphony of life in ways we have yet to understand. There's a possibility that life itself could consist of diverse combinations of elements evolving from cosmic dust in plasma. Recent studies have confirmed that inorganic dust comprised of iron, silicon, magnesium, and carbon exhibits astonishing lifelike behavior within plasma. Under certain conditions, these particles can combine to create complex compounds that allow for interactions similar to those found in organic matter. Previously, scientists believed that solid particles in cosmic plasma merely created thread-like formations. However, through advanced computer modeling, scientists have discovered something interesting. These thread-like structures have the ability to arrange themselves into spiral or helical shapes through self-organization. Even more surprisingly, researchers have discovered that these formations can engage in interactions and undergo transformations similar to those observed in DNA and proteins. These mysterious helices and spirals formed by solid particles can divide or replicate, creating two copies of the original structure. Through interactions with each other, they change and evolve. During this process, the plasma keeps the most well-adapted copies while getting rid of the less stable ones. Somewhere out there in the universe, there could be a living helix in a cosmic plasma cloud, slowly evolving into a much more complex organism. Or maybe there are nanomicrobes that have settled on a neutron star. These creatures, according to astrophysicist Frank Drake, would be made up of tightly packed nuclei instead of regular atoms, forming nuclear molecules. Their lives would be incredibly short due to the fast nuclear reactions. If they existed, they would only live for a few minutes and would only be visible under a microscope. But then let us consider the opposite. What if there are enormous beings in the cosmos observing us like we observe microbes under a huge microscope? How big could these creatures be? The size of elephants? Or even larger, like an entire ocean, a planet, a galaxy, or even a cluster of galaxies? Maybe they encompass the entire universe. Life might not necessarily rely on atoms and molecules, but could be intricately interwoven with the very fabric of the cosmos. According to this idea, life is omnipresent, existing in a seamless manner all around us. This thought challenges conventional assumptions and invites us to contemplate the profound nature of life in the broader context of the universe. Which idea resonates most with you? Share your thoughts in the comments below. If you found this video interesting, make sure to stay tuned for more captivating cosmic findings. Thanks for watching.